Welcome to section 3.5. This is the 30th session of the ISACA CISA exam prep series. In this session, we'll cover system readiness and testing. We'll answer several questions. Why do we test at all? What are the main levels and types of testing? How do you test that data stay intact? Which techniques let an auditor test the application? And how do you move a tested system into production? Why does this matter beyond the exam? Because testing is the last gate before real users depend on a system. Picture an airline launching a new booking engine. Skip proper testing and a busy weekend exposes every flaw. Test well and you ship with confidence and evidence. Your role here is preventive and detective at once. You make sure the right tests happen and you read the results. Why do we test at all? To verify and validate that the system does its job. Verify means it works as designed. Validate means it does what users actually need. Testing also confirms it doesn't break other components. Each level of testing uses different data and different people. What are the main levels of testing? They build up from small to whole. Unit testing checks a single program or module. Integration testing checks how components pass data between them. System testing checks the whole assembled system. Within system testing, several flavors exist. Recovery testing checks it bounces back after a failure. Security testing checks for access controls and holes. Load testing pushes large data at peak conditions. Volume testing finds the maximum record count it handles. Stress testing finds the maximum concurrent users. And performance testing compares it against benchmarks. Then comes final acceptance testing. It has two distinct halves. Quality assurance testing checks the technical specifications. User acceptance testing checks the functional needs. They have different goals, so never combine them. Run acceptance testing in a secure, staged environment. And test acquired software yourself, never just trusting the vendor. Otherwise, you risk slipping in a malicious patch. Are there other types of testing to know? Yes, several. Alpha testing is internal. Then beta testing goes to outside users. Pilot testing checks specific aspects on a limited basis. White box testing examines the internal logic paths. Black box testing checks function without looking inside. Function testing traces the build back to requirements. Regression testing reruns old tests to catch new breakage. Parallel testing feeds the same data to old and new systems. And sociability testing confirms it plays nicely with its neighbors. How do you plan and approach the testing itself? Test plans name what gets tested and how. They rank the severity of problems found. That severity decides whether you fix now or fix later. There are two reciprocal approaches. Bottom-up starts with the smallest units and builds upward. It needs no stubs and finds errors in key modules early. Top-down starts with major functions first. It detects interface errors sooner and shows a working system. How do you test that data stay intact? Data integrity testing checks accuracy and completeness of stored data. Because checking the whole file is heavy, you often check in cycles. Two integrity tests matter. Relational integrity works at the record level through validation routines. Referential integrity makes sure related tables stay consistent. Every foreign key must point to a real record. And for live transaction systems, remember the ACID principle. Atomicity means a transaction completes fully or not at all. Consistency means the database stays valid through every change. Isolation means transactions don't interfere with each other. Durability means a completed transaction survives a crash. Which techniques let an auditor test the application? There's a toolbox here, so let me group it. Some techniques trace transactions through the code. Snapshot records the flow through logic paths. Mapping spots code that was never tested. Tracing and tagging follow marked transactions through the program. Some techniques run test data through real programs. A test deck simulates transactions to verify controls. Base case evaluation uses comprehensive test datasets. An integrated test facility runs fictitious data alongside live data. Some techniques compare two runs. Parallel operation runs old and new programs on the same data. Parallel simulation reprocesses real data through simulating programs. And some techniques embed the audit into production. Transaction selection screens live transactions independently. Embedded audit collection captures transactions as they process. Two variants here are worth a name. One captures transactions meeting set criteria for review. The other randomly samples transactions for analysis. To pull this together, auditors often use generalized audit software. It's especially handy when you find a specific control weakness. So testing is done. How do you move the system into production? Only after testing succeeds and under change control. Confirm the right sign-offs were obtained first. Check that documentation is complete and current. And verify every data conversion is correct before go live. A new system also needs a real support structure. Setting that up is a project in itself. You need support teams at the first, second, and third tiers. You need a single point of contact and defined roles. And you often run the old and new platforms side by side for a while. How do you transfer knowledge to support staff? Use shadowing and the relay baton method. Shadowing lets staff learn by watching the system. The relay baton passes knowledge in small, deliberate handovers. And don't forget the training plan. Document content, scheduling, duration, and delivery method. Base it on role profiles and the skills gap, and respect that staff still run the current system while training. So let's bring it together. Testing verifies and validates, level by level. Quality assurance and user acceptance testing stay separate. Integrity tests and the ACID principle protect the data. Auditor techniques range from tracing to embedded collection. And a clean move to production needs sign-offs, support, and training. The MCQs covering all the topics and concepts from this session are available on RooCloud.com. Practice the chapter-specific MCQs before moving on to the next session. Thanks for watching. If you have any questions or feedback, post a comment below or email us. I will see you in the next session.